Thermodynamics. The word thermo means heat and the word dynamics represents movement. So, literally, the word thermodynamic means movement of heat. But actually, thermodynamics deals with the relation of heat and work. Before we going to the details of thermodynamics, let us familiarize some terms coming under this chapter. The first term is system and surrounding. System means a part of the universe in which thermodynamic study is conducted. For example, if we consider a cylinder containing two gases, nitrogen and oxygen and nitrogen, and we are going to study about this cylinder. So, now this is the system. That is, this is a system. All other parts except the system is known as surrounding. Surrounding means all other part except the system. The system and the surrounding collectively called as universe. Then next one, types of system. Types of system. We can classify the system into three based on the exchange of energy and matter. Based on this criteria, system is classified into three. The first one is open system. Next one, closed system. And the third one is isolated system. The first one is open system. If there is an exchange of energy and matter occurs between the system and surrounding, then it is called open system. Exchange of both energy and matter occurs between the system and the surrounding, then it is called open system. For example, consider a cup containing some hot tea. Here, the cup with the hot tea can be considered as a system. And all the remaining portion is taken as surrounding. If we kept this hot tea for some time, we know after some time, energy as well as matter will exchange. Here, a small portion of the matter is evaporated out. That is, exchange between the system and surrounding. And if we kept it for some time, cooling will occur. That means heat energy exchange is also occurs between the system and the surrounding. So we can say that is a cup containing hot tea is an example of open system. Then coming to closed system. Then second one, closed system. In a closed system, exchange of energy will occur while Exchange of matter is not happening there.
So, if we consider the same example,
A cup containing some hot tea.
and if we close this with a lid, close the mouth of this cup with the lid, what happens? Exchange of energy occurs. Exchange of heat energy is occurs. But the matter will not exchange. Matter is not exchanges here.
So, closed system is one which can exchange energy but not matter.
Then the third one is isolated system. Isolated system. Isolated system means neither the exchange of energy nor the exchange of matter happens between the system and the surrounding. For example, if we consider a flask, if you take the hot tea in a flask, here neither the exchange of matter nor the exchange of heat energy occurs. That means it is an isolated system. Then next one, macroscopic properties. Actually, the properties associated with the macroscopic systems are known as macroscopic properties. Macroscopic system means a system consists of large number of particles. Okay. Macroscopic properties means some properties associated with the macroscopic systems. Macroscopic system means a system which consists of large number of particles. Some examples of macroscopic properties are pressure, temperature, composition, number of molecules, viscosity, density, refractive index, etc. are macroscopic properties. If we classify the macroscopic properties, we can classify this into two. First one, intensive properties, and the next one is extensive property. This classification, that is intensive and extensive classification, is differ by whether this property is depends upon the amount of substance or not. If a property does not depend upon the amount of the substance, then it is known as intensive property. While extensive property means a property which depends upon the amount of substance. Some examples of intensive properties are pressure, temperature, density, concentration, viscosity, refractive index, etc. Are intensive properties. While extensive properties are mass, example mass, volume, heat capacity, and almost all the almost all the thermodynamic quantities are thermodynamic functions are extensive properties. Extensive properties depends the amount of substance. These are additive properties. These are additive properties. While the intensive properties does not depend the amount of substance, and these are not additive. And one more thing is there, that is, if we take two extensive properties, example, we can take mass and volume. Mass and volume are extensive properties. That is, both these properties depends the amount of substance. If we divide mass divided by volume, the answer will be density. Here, density is an intensive property. That means if we divide two extensive property, the quotient obtained will be an intensive property. This is not only for these two examples. If we divide one extensive property by using any other extensive property, the quotient obtained will be an intensive property. The next term is state function, state variables, and state function. State means it is the condition of existence. State means it's a condition of existence of a particular system. Condition of existence. And state variables means the variables we used to express this particular conditions. Variables used to express a particular condition is known as state variables. That is, if a system is in a particular state, then we can express this condition by using some variables like pressure, temperature, density, mass, heat, enthalpy, energy, etc. So, all the variables used to express a particular state of a system is known as state variables. Then, the next one is state function.
We are studying about any thermodynamic system. That actually means we are concentrating the changes happening in that system.
If the changes happening in that system is only depends upon state, then it is known as state function. Once again, if the changes happening in a particular system,
Change in a system
is only depends the state, then it is known as state function. For example, the properties like pressure, temperature, and thermodynamic variables like entropy, enthalpy, etc.
are only depend the path of the function.
What are the path in which a system used for the change is not considered here. Here, the only concern is about the initial state and final state. Anyway, whatever the path used by the system,
The only concern is for initial and final state.
All other things except the initial state and final state are not relevant. Then it is state function. So if if a change depends the path, then it is named as path function. It is named as path function. So path function and state functions are there.
Path function depends the path while state function does not.
Then thermodynamic processes.
Different types of thermodynamic processes are there, and these processes are classified on the basis of the parameter which is taken as a constant.
So we can take 4 different processes. The first one is isothermal process, and the second one is adiabatic process. Adiabatic. The third one is isobaric, and isochoric. Isothermal means temperature is constant. That is, change in temperature is equal to 0. That is, dt is equal to 0. That is, if a process in which temperature is kept constant, then it is isothermal process. While adiabatic process means there is no exchange of heat, or there is no change in heat energy. That is, dq equal to 0. Then it is known as adiabatic process. Here dt equal to 0, that doesn't means dq equal to 0. Here dq not equal to 0. Same way, here dq equal to 0 in adiabatic process, but dt not equal to 0. In isobaric process means a process which is conducting at a constant pressure is known as isobaric process. So dp equal to 0, that is change in pressure equal to 0. Isochoric process means a process which is conducting at a constant volume, that is dv equal to 0. Isothermal, adiabatic, isobaric and isochoric. Then next one, cyclic process. Cyclic process. Cyclic process means cyclic system means consider a system whether after a series of changes it come back to initial position, then it is known as cyclic process. That is, the system undergoing different changes are happening and convert back to the initial state. Then it is cyclic process. And this path is known as, and this path is termed as cyclic path. Then the last one, reversible process and irreversible process. In some reactions, the direction may be reversed. That is, if A is converted to B, sometimes B can be converted back to A. Then the direction is reversed, then it is known as reversible processes. While in irreversible processes, the change occurs in only one direction. The direction will not be reversed. Such changes are known as irreversible changes. Here, direction reversed. Here, not reversed. These are all about the basic terms used in thermodynamics.